A university study proved that a $2 plastic sheet cuts heat loss through a window by up to 50%. Not a new technology, not a prototype. A technique that's been used for decades across the northern United States and Canada. The University of Minnesota measured it. Energy.gov confirmed it. And in most apartment buildings in this country, fire codes make it illegal. Let that land for a second. The HVAC industry generates $133 billion a year. Billion. That's furnaces, heat pumps, ductwork, service contracts, annual maintenance visits, an entire economy built around keeping you warm. The plastic sheeting that nearly doubles your window's insulation costs less than a cup of coffee. And nobody in that industry will ever mention it to you. By the end of this video, you'll know exactly how to insulate every window in a room for under $10 total. Hardware store materials, no electricity, no special skills, plus a NASA-developed technique that turns your walls into heat reflectors. So why has almost no one heard of this? Welcome to the channel. What we do here is simple. We find the techniques that are too cheap to advertise and too effective to ignore, the stuff that falls through the cracks because there's no profit margin attached to it, no brand, no subscription, no upsell. If you believe practical knowledge shouldn't require a sales funnel, hit subscribe. You're in the right place. Now let's start with what actually happens when heat meets glass. Glass is the weakest thermal link in any building. A single pane of glass has an R value of 0.9. For context, or your walls are insulated to R13 or R21. Your windows are practically holes in your house. Heat doesn't just leak through them, it pours. Now here's the principle. Dead air insulates. That's it. That's the entire mechanism. If you trap a layer of still air between two surfaces, heat transfer slows dramatically. This is how double pane windows work. This is how layered clothing works. This is how storm windows have worked for centuries. Two surfaces, dead air between them. Physics does the rest. When you stretch a sheet of clear plastic over a window frame, you create that trapped air pocket. One layer of plastic over a single pane window adds an R value of 0.85. You've nearly doubled the insulation. Two layers bring it to R1.25. You haven't replaced the glass. You've just given it a partner. This isn't new science. People in Minnesota, Wisconsin, Michigan, and across Canada have been doing this since before commercial kits existed. Rural households, low-income families, people who couldn't afford to replace every window in the house. They bought plastic sheeting. They taped it up. They survived winters that would kill you. Commercial window insulation kits appeared in the 1970s and 1980s. They're still sold today. Same principle, same physics, same $2 solution to a problem the heating industry charges thousands to address. So the physics work. The history is there. Now here's where it gets interesting. What you're watching right now is the surface layer. Behind this channel, we maintain a vault of deeper research, grid-down heating strategies, emergency water purification, long-term food preservation without refrigeration, shelter construction from salvaged materials, medical knowledge for when the system isn't coming, communication methods when the grid is dark, no fluff, no filler, just the information you'd want if everything stopped working tomorrow. Link is in the description. But right now, let's talk about why a $133 billion industry doesn't want you thinking about plastic sheeting. In 2007, the University of Minnesota conducted a study on window insulation films. They found that a simple plastic covering reduced total heating energy consumption by 14%. Not 14% through the window, 14% of the entire heating bill. Energy.gov backs this up with a broader range. They estimate window treatments like plastic film reduce heating costs by 10 to 30% depending on the home. Now hold those numbers and follow the money. The HVAC industry in the United States pulls in $133 billion annually. Heating equipment manufacturing alone accounts for $62.5 billion, and here's the number that matters most. 62.5% of equipment sales are retrofits. That means the majority of the industry's revenue comes from replacing and upgrading systems in existing homes. Homes with older windows. Homes where a $2 sheet of plastic would reduce the load on the very equipment they're selling you. Polyethylene sheeting is a commodity material. You can't patent it. You can't brand it. You can't attach a service contract to it. There's no installation fee, no annual maintenance visit, no app, no smart thermostat integration, no recurring revenue stream. It is the financial opposite of everything the heating industry needs to exist. Industries promote what they sell. They don't promote what makes their products less necessary. This isn't a conspiracy theory. It's a business model. You don't need a secret meeting in a dark room. You just need quarterly earnings pressure and a product that doesn't generate profit. But the money isn't even the worst part. The International Building Code, Chapter 26, regulates the use of plastic materials in construction. And the reasoning is legitimate. Polyethylene is combustible. It melts, it drips. When it burns, it produces toxic fumes. In a fire, Plastic sheeting on windows can accelerate flame spread and compromise egress. Local fire codes in most municipalities ban or restrict interior plastic coverings in multi-unit residential buildings. That means apartments. That means affordable housing. That means the exact buildings most likely to have old single-pane windows and the highest heating costs per square foot. Read that again. The populations most burdened by energy costs are legally prohibited from using the cheapest insulation method available. Renters in older buildings with the worst windows in the country cannot legally tape $2 worth of plastic over them. And here's the part that should make you pause. FEMA, the Federal Emergency Management Agency, explicitly recommends plastic sheeting for shelter-in-place emergencies. The federal government tells you to put plastic over your windows when there's a chemical threat, but your local building code will fine you for putting the same material on the same window to keep your family warm in January. That's not a contradiction anyone in power is in a hurry to resolve. Now, let's be honest about what this can and can't do. First, plastic sheeting is supplemental insulation. It is not a heat source. You still need some form of heating. A wood stove, a space heater, body heat in a small room. The plastic slows heat loss. It doesn't generate warmth. Second, this technique is most effective on older single-pane windows. If you have modern double-pane or triple-pane windows, the benefit is minimal. You've already got trapped air engineered into the glass. Adding plastic on top may save you a few percent, but it won't be dramatic. Third, polyethylene is genuinely combustible. This is not fear-mongering. If you install plastic over your windows, you must maintain at least one egress window per room that you can open and exit through. You must have working smoke detectors. This is non-negotiable. Fourth, the R values are modest compared to wall insulation. You're going from R0.9 to R1.75. That's a meaningful improvement for a window. It is not comparable to the R13 in your walls. Windows remain the weak point. You're just making them significantly less weak. Fifth, condensation can form between the plastic and the glass. Over time, this moisture can cause mold growth on the window frame. In humid environments, inspect behind the plastic periodically and ensure the seal isn't trapping excessive moisture. Now that you know the real boundaries, here's exactly how to do it. Materials: clear polyethylene sheeting, 3 mil thickness or thicker, available at any hardware store. Or a commercial window insulation kit, which includes the plastic and tape together. Either option costs $2 to $5 per window. Double-sided tape, 3/4 inch width, scissors, and a hairdryer for shrinking or hand tension if you're working without power. Step 1. Clean the window frame thoroughly. The tape needs a dust-free surface to hold all winter. Wipe with a damp cloth and let it dry. Step 2. Apply double-sided tape around the entire perimeter of the window frame. Not the glass, the frame. You want the plastic stretched across the frame so the air gap forms between the plastic and the glass surface. Step 3. Starting at the top, press the plastic onto the tape. Work down one side, then the other, then the bottom. Keep it taut, but don't stretch it tight yet. Step 4. Use the hairdryer on medium heat, held 6 to 8 inches from the surface. Move slowly across the plastic. It will shrink and pull taut like a drum skin. This removes wrinkles and creates a clean, transparent seal. Step 5. This is the critical measurement. The air gap between the plastic and the glass must be 3/8 of an inch to 3/4 of an inch. The plastic must not touch the glass. If it touches, you've eliminated the dead air layer and lost most of the insulating benefit. Now, south-facing windows get special treatment. Use only clear plastic on south-facing glass. Here's why. Sunlight enters through the clear plastic, hits the floor, furniture, and walls inside, and heats those surfaces. That heat radiates as infrared energy. Infrared cannot pass back through the air gap as easily as visible light came in. You've created a passive solar heat trap. On a clear winter day, this is measurable, free thermal gain. Do not put opaque or tinted material on south-facing windows. You'd be blocking your free heating system. And here's the NASA bonus. In 1964, NASA developed metallized mylar for spacecraft thermal insulation. You can buy it today as emergency blankets or reflective insulation rolls for a few dollars. Cut a piece and mount it behind your radiator or on the interior wall opposite your heat source. The mylar reflects radiated heat back into the room instead of letting it absorb into the wall and dissipate outside. This isn't folklore. It's the same material that keeps satellites from freezing in the shadow of the Earth. Grid down protocol. If you lose power in winter, consolidate living into the fewest rooms possible. Insulate those windows first. Close doors to unused rooms. Roll towels and press them against the gap at the bottom of each door. You're creating a thermal core. The smaller the space, the less heat you need to maintain survivable temperature. Step back and look at what you just built. A layered thermal retention system. Plastic sheeting on the windows to trap dead air. Clear plastic on south-facing glass to capture passive solar gain. Mylar on the walls to reflect radiated heat back into the room. Total cost: under $10. Electricity required: none. Special skills required: none. Time to install a full room: under an hour. The reason you've never heard of this isn't suppression in the way people usually mean that word. It's structural neglect, a technique too cheap to market, too simple to professionalize, partially restricted by code in the exact buildings where it would do the most good. The $133 billion industry that owns the heating conversation has no product here, no margin, no angle. They have no reason to bring it up. And so it stays invisible, passed along in rural communities, remembered by people who lived through winters without money, forgotten by everyone else. Now you know, the physics are settled, the university data is published, the materials are at your nearest hardware store, and the total investment is less than what you'd spend on a coffee. Share this video with someone who pays a heating bill. That's all it takes. If you believe practical knowledge shouldn't be gated behind a price tag, subscribe. We'll keep finding these. The next one might matter even more.